Hello, so today, continuing on contest 168, let's take a look at this problem called maximum number of occurrences of a substring. And so the problem says that we get a string S and we want to return the maximum number of occurrences of any substring under these two rules. The first rule is that the number of unique characters in the substring must be less than or equal to max letters. The second rule is that the substring size must be between min size and max size. So these are the two rules that we have. For the first example, we have this string, max letters is 2, min size is 3, max size is 4. And so if we look here, if we take the substring of length 3, AAB, it occurs 2 times, right? And its unique characters are 2, and so it is less than or equal to max letters. And it is in its size is 3, so it occurs so it's in the range the 3, 4 inclusive. And the number of substring, the number of the occurrences of it is 2, and so we return that, because if you look and try to find any other substring that occurs more than 2, there isn't any substring like that, because, well, the only one that occurs like multiple times again is AB and AA. AA has 1 unique character, so it doesn't conform to the first rule. AB has 2 unique characters, but its size is less than 3, so it's not in the range, so it doesn't conform to the second rule. So you get the idea. We want the substring that occurs the most and follows these two rules, essentially. If you look at this example, the string that has that, it's AAA 3 times, and you could see here that they can overlap. And maximum here, the unique letters, number of unique letters is just 1, and the min size is 3, right? So the min size is 3, so that tells you that since the min size is 3, AAA has size 3, so it follows the rules, so that's good. And you could take a look at the rest of the examples, but essentially that's the idea. And min size, max size are just from 1 to 26. We have only lowercase English letters, and S can be relatively big. So let's see how we can solve. Okay, so how can we solve this problem? So a couple of things that we can, so the rules that we have that the problem gives us is that so we want the maximum number of occurrence of substrings, and the rules are the following, right? So we have the first one and the second one. The first one is that number of unique characters should be less than or equal to max letters. And the second one is that length of the substring should be in the range inclusive of min size and max size, pretty much. So these are the rules that we have. Now, how can we approach this problem? So the one thing we can think of is, okay, let's just construct these strings. Let's just these substrings, and basically just count the occurrences of each substring that is valid according to these rules, and then take the maximum. So a very straightforward approach. And so to do that, what we need is just well, we need to construct these strings, right? This constructing them with the first rule is kind of hard, but with the second rule is pretty easy. So what we can do is just in our approach here, what we can do is just first we can just construct substrings that are valid for the second rule, right? And then once we do that, what we can do is construct all substrings, right? All of them, which means including, so this is very important here, so including substrings that overlap, right? Substrings that overlap. What I mean by this is, in the case, in one of the examples where we had AAA, and the substring that we considered was this one and this one, so you can see that they overlap. So we need to try every starting point and take only those that are valid with the range 2, which basically means take every start I and then just try I plus min size, right? The word starting at I and of length min size, and try the one of length min size plus 1 starting at I, and then the one with size min size plus 2 starting at I, until the one starting at I and of length max size, right? So basically try all the valid ones according to rule 2, right? And then once we do that, we can check at every step. So basically check if substring that we just generated here is valid for the first rule, right? Because if it is, that means it's a candidate to be maximum number of occurrences of a substring, right? So basically that means if valid, that means it's a candidate solution, basically. And so how can we keep track of the candidates so that we can get the maximum number of occurrences of a substring? So to do that, we can just keep a map, right? So just use a map here. So basically use a map from word, right? Or from a substring, since that's what we are exploring here, from a substring to the number of its occurrences, right? And so this map here will contain only the valid words, right? And basically once we do this, it will contain only valid words. We will have all the valid substrings according to these two rules and their number of occurrences, and so in the end we can just take the max, right? So in the end, return the max. The substring that occurred the most among the valid substrings. You will notice here in this construction, what we did is we add to the map only the words that are valid according to these two rules, right? And so how can we do the construction, the first step, the construction? How can we do that? So we could just start, right? We could just start from every position, right? So we just do for I in a range of n, right? And then, so we start from every position, and then we try all the valid substrings according to the second rule, right? And so to do that, we say for its ending position has to be in the range I plus min size plus minus 1, right? Because if it starts from I, then I gets counted. When it reached minus size I plus minus size minus 1, the length would be minus size. And here I plus max size, right? And since in Python range stops at the position before, it would be max size minus 1, and that word would have size max size, right? Except there is one caveat, which is maybe I plus max size is more than the length of the string, so we just need to add min here for this and n to make sure such that n is just the length of the string, to make sure we don't go out of bounds, right? Okay, so now these are here at this position. We know that S I to j plus 1 is valid for rule 2, right? Because that's literally what the construction that we did. It's size. We generated words that have size that is in the range min size, max size, right? Inclusive. Okay, so now what is this substring that we are dealing with here? So the substring is this S from I to J, right? And so we do J plus 1 for Python so that it includes the character at position J. And now we do the second step, which is we check that the substring is valid for rule 1, which means its number of unique characters is less than or equal to max letters. And so to do that, we do if to get the unique characters, we just take the length of the set for the substring, and we check that it's valid, which means it's less than or equal to max letters, right? Now, if it is valid, so this here means valid for rule 1. So if it is, what we said is we're going to use a map that keeps the number of occurrences of the substring, because at this point it's valid for both roles, so it's a possible solution. And so we need to have a map here that stores these. So let's just call that map occurrences, right, like this, and let's initialize it to be collections in Python default dict. So basically this is just so that it will be initialized with the zeros, so that we don't need to initialize it. And here the occurrences of the word substring increased by 1, right? And so we did that so that we can keep track of how many times that substring occurred. And now at the end, to get the maximum occurrence valid substring, we can just return max of these occurrences values, because the values would be the number of occurrences, right? And we are interested in the number of its occurrences, so that's what this will get us. And just to avoid the problem where occurrence may be empty because we didn't find any valid word, we're just going to default to 0, right? In Python, this would say if occurrence is empty, just return 0, basically. And that's pretty much it. So we just went through every position, generated a word that is valid using the second rule, which means its length is in the range that the problem asks us for. And then we check if its length, if the number of unique characters is less than or equal to max letters, so that it's valid according to the first rule, and then we increase the number of its occurrences, and at the end we just return the max. Okay, so let's type this into Leetcode and see if it passes the test cases. Okay, so I just typed the solution that we just did in the overview here. So just constructing the words that are valid according to the first rule, which is the size and the range that we want, and then checking that the number of unique characters is less than or equal to max letters. If it is, we count many times it occurred. At the end, we return the max. And so let's run this and see. Okay, so it looks like it's good. Submit. Okay, so the solution passes. Now in terms of like time complexity and space complexity, this solution here we do O of n, and here we do the range max size minus min size. So if I take m to be max size minus min size, and here we have O of n, so the overall time complexity would be O of n m, right? So overall we would have O of n m time, and then in terms of space complexity, the only expensive space thing we are using here is this map, which contains maybe all the substrings, which can go into to be O of n squared space, right? And so that's the space and time complexity analysis. So another small optimization that we can do here is we actually can avoid doing this max that will do a pass over all the values of the occurrences by just having some result variable here that we initialize to 0, and then at this position here, when we increment, we could just say, okay, res is going to be a max of res and the occurrences of this word that we just, substring that we just increased, right? And then at the end, we just return result. So that's one way we can optimize this, a small way we can optimize it. Okay, so that passes. Now, another way we can think about this is to optimize this even further to an Venn solution, is that, well, if we find a word that is of size min size, right, that is valid according to the two rules that we have here, or actually if we find a word, a substring that has size, let's say anything bigger than min size, right, that is valid, right, which means that it has unique characters less than or equal to max letters. So that means that that substring, right, is valid. So basically, let's say if we find a substring of size x, let's say that is bigger or equal to minus size, that is valid. That means that a substring of x, right, is also valid, right? Substring of x with length min size, right? Min size is also valid, right? Because, well, it's valid according to the second rule because its size is min size, and it is valid according to the first rule because if x the unique characters of x are less than or equal to max letters, that means that a substring of x also, let's call this substring of sy, a substring y of x, that means also that the unique characters of y are less than or equal to max letters, right, by definition, because, well, its parent has less than or equal to max letters, and since y is smaller, it also has less than or equal to max letters. So that means that this one here is also valid, and this one certainly occurs either the same amount of times, or maybe it occurs more, because maybe x is just y, right? It's just like in this format right here, right? And so whenever you have one that is bigger than, that its size is bigger than min size, that means we can just take a substring of it that is of size min size, and it will give us the maximum number of occurrences. So basically that means we don't need to check max size, and we don't need to check anything bigger than min size. We can just check min size, and that will be enough. It will always gives us the max occurrence. And so to do that, then we can just not do this, not go through every possible size between min size and max size, and instead we can just take I to be any starting point that can give us a size min size, right? And so that would be min size plus 1, right, like this. And now our substring, instead of j, it would be just I plus min size, since we know that if there is a solution that has the maximum occurrences, it must have size at least min size. So we can just do that this way, and now just check if it's valid, and that would be enough, right? And so and that's pretty much it, and we can just return the result, and we just did O of n instead, so we don't need to check max size at all or anything bigger than min size. So let's submit this one and see. So you can see it passes and it's a lot faster. And in terms of time complexity, this one is actually just O of n time, right? And in terms of space, it's still like O of n space, but it's a lot faster. And this is just by noticing that we actually only need to check the substrings of size, min size, right? Yeah, so that's it for this problem. Thanks for watching and see you next time. Bye.